Hey guys, today we're taking a look at 2.2, looking at some characteristics of our parabolas. So in this, a lot of the words will be familiar to you. There really should be just one or two new ways of describing a parabola that we didn't talk about back in Algebra 1, so it should be mostly review besides that one new thing. So when we're looking at a parabola, if we already had something graphed, and really the equation for today isn't important. We're looking at just taking something that's already graphed and being able to describe it using, we've got 5 main characteristics. We talk about its vertex, its axis of symmetry, its intercepts, its domain, and its range. Those are the big 5. We have 7 in total. We'll also talk about their intervals of increasing and decreasing. And kind of a quasi-eighth thing, we're talking about the function's max or min value, but really that just stems from the vertex. So really 7 things, but those big 5 are going to be the most important ones. Again, vertex, AOS, intercepts, domain, range. So in this graph that we're looking at right here, if we're asked to describe this, I've even got a nice little word bank in here. The most obvious one to us should be its vertex. That is always the lowest or highest point in my graph. So in this case, my vertex is this point right here, right? My vertex, that is the bottom of my curve or the top of my curve, depending on which direction it opens. That's just the highest or lowest point. The parabola itself is symmetrical, so we know that it reflects over upon itself left and right with our parabolas. And where that line happens, like where that reflection would happen, is what we call our axis of symmetry. So in this case, our axis of symmetry, I'm going to run out of room, so I'm going to write it down below. Symmetry is always a vertical line for our parabola, and it always goes through that vertex. Because if my vertex is my lowest point in this case, then that point is the middle of our graph, so our AOS is that vertical dotted line that goes through the center of my graph. The rest of these that are labeled in my picture are just my different intercepts. So my x-intercept, we have one there and there, because that, again, an intercept is where it crosses that particular axis. So here, -3 and +1 are my 2 x-intercepts. And then this right here is my y-intercept. That is where it crosses the y-axis, 0, -3. For my domain and my range, for my domain, remember domain is my x values, so looking at all the different possibilities for what x could be in my function. And for quadratics, for parabolas, it's always going to be all real numbers as long as it's opening up and down. We'll get it once we get into like 2.4. We'll look at some sideways parabolas where we might have a restriction for our x values for our domain, but then our range is going to be all real numbers instead. For my range, again, what my y values are, if I look at it in terms of the heights, I have my lowest point being -4, and I go all the way up as high as I want to. That even continues on further beyond just what I see on my graph. So the way that I would describe that, my range has a smallest value of -4, which means all of my y values have to be -4 or bigger. So y is greater than or equal to -4 would be my range. And that's always going to be the case. You're always going to have your y value either greater than or equal to the y value for your vertex, or if it was a downward opening parabola, you would have y is less than or equal to whatever the y value is for your vertex. So those are the main ones. Those are the most important ones that we'll continue utilizing throughout the school year. The last 2 are the newest ones, and these are their intervals of increasing and decreasing. So this is actually something, if you're going to be a student who ends up going on and continuing past Algebra 2, if you're going to go on to pre-calc and calculus and you have a future in math, looking at where intervals are increasing and decreasing is something that is a common theme as we move on into the upper level math classes. We start looking at derivatives where we can look at those different inflection points, and you get into some kind of cool stuff in terms of analyzing graphs. So in this, the way that I would characterize this, we have different places where as you move from left to right in my graph, my outputs, my y values, are either going to be going up or they're going to be going down. So anywhere as I move left to right where my y values get bigger the further to the right you go would be an interval of increasing. anywhere as you move from left to right on my graph, if my y values are going down, that would be an interval of decreasing. In parabolas, you always have one of each. On one side of your parabola, the y values are going down. On one side of the parabola, the y values are going back up as you move left to right. So in blue, if I look at my two different zones here, I'm going to highlight this in blue first. So I've got, as I move left to right, my y values, until I hit the vertex right here, are decreasing. Right? As I move from the left side of my parabola down towards the center, those y values are going down to the vertex. So I would call this right here, this left side of my graph, decreasing. If I look on the right side, after I hit that vertex and I continue moving to the right again, now all of these values are going up. Right? All those y values keep increasing. So this right side of my graph would be, oops, if I can spell, increasing. So those are where the different zones are for increasing and decreasing. So for increasing, that was the right side of my graph. I'm just going to describe it that way, and then I'll show you how we actually write it up. And then the left side of my graph in this parabola was decreasing. Now the way that we write these, we have to describe it using some actual mathematical terms, not just left side, right side. We have to know what x values I have so that my outputs are increasing or decreasing. So you kind of have to imagine this as like a number line. If you're looking at the x values, all of my x values from negative infinity all the way up until they hit this x value of, what is this, negative 1? That's where my AOS happens. Everything up until negative 1, my y values are going down. That's the blue side. They're decreasing. And then everything after that, after negative 1, all the way to infinity, my x values get bigger, my y values get bigger. So that would be our interval of increasing. So the way that we write this, it actually looks pretty similar to our range. It's now going to be x is either less than or greater than. So in this case, the right side of my graph is our interval of increasing, which means anywhere my x is bigger than negative 1 is going to be increasing. So that means anywhere x is less than negative 1 is going to be decreasing. Now, just like we had before, if you think way back to Algebra 1, when we were doing inequalities, if you follow this structure, if you guys notice, if you keep the x value on the left side of your inequality and the x value of your vertex on the right side, the direction that the arrow points, your inequality points, is the side of the parabola you're trying to describe. So in our interval of increasing, we were describing the right side of my graph, and hey, look, my inequality points to the right. On the interval of decreasing, the left side of my graph is the one we were trying to describe, and hey, look, my inequality points to the left. That will always be the case as long as you keep the variable on the left side, the number on the right. Then you can just look at, okay, left side, right side, just make sure my inequality points the same direction. Now that's pretty much it. That is everything we need for 2.2. So I'm going to do one or two more examples of just identifying these things, and they'll go a lot quicker now that you see them. So for number 1, this one will look very similar. Now when we list them out, instead of just pointing to them, you just have to make sure formatting-wise it matches. Our x-intercepts, our y-intercept, and our vertex, all three of those things are points. So they should be ordered pairs when you're listing them out. So my x-intercepts are here and here. So the way that I would describe those would be negative 1, 0, and 4, 0. My y-intercept happens right here at negative 4. So 0, negative 4 would be that point for my vertex. Sorry, not for my vertex, for my y-intercept. Not the cleanest one. I should have probably switched this and made it a little bit nicer. My vertex here happens halfway between 1 and 2, and it looks like just a little bit less than negative 6. So I'm just going to approximate this to be 1.5, negative 6 1/4. With something like this, on a test or a quiz, it'll be on one of the nice grid markers so you know definitively what they are. But in this case, just do your best to approximate what it is. If it's not perfect, then be as close as you can. A max or a min. So this one we didn't talk about on the front side. when we have a point on our graph that is the highest or lowest point, that's just how we describe it to be a maximum or a minimum. Now, in this case, because my parabola opens up, my vertex is the lowest point, so it is a minimum value for that function. My vertex is the minimum value of that function. For my AOS, we know that that is this dotted line that goes right through your vertex. Since we're trying to write the equation of a vertical line, the equation for that is always x equals some number, wherever it is horizontally. So in this case, 1.5 was the x value we're using for our vertex, so x equals 1.5 would be our equation for the AOS. Domain, always real numbers. Oh, sorry, always all real numbers. Darn. Our range, now if we have negative 6.25 as our lowest value, our range should be y is greater than or equal to negative 6.25. And then last but not least, our intervals of increasing and decreasing. We can see that the left side of my graph, once again, is going down as I move to the right. The right side of my graph is going up as I move to the right. And again, that boundary for where my intervals are is that AOS, because as soon as you hit the vertex, it stops decreasing and starts increasing. So my increasing interval, since that's the right side, would be x is greater than 1.5. My interval of decreasing would be x is less than 1.5. Okay. For the last one, number 2, this one a little bit different just because it opens down instead of up, but pause the video for a second, try this one on your own, and then once you have all your answers or what you think all your answers are, then go ahead and hit play again and we'll go through this together. Okay, so hopefully you guys took the chance to go through that one. Let's take a look together. My first couple should be the same. It's really just the intervals of increasing and decreasing that'll look a little bit different. My 2 intercepts here for my x's are at negative 1, 0 and 2, 0. My y-intercept is 0, 4. My vertex here, a little bit different again because we're at not quite, I'm going to say this is just a half, so 0.5, and I'm going to call that just 4.5, just approximating. It's about halfway between 0 and 1 and 4 and 5. This one is a maximum value because that is the highest point of my graph now. It's curved upward. The curve happens and it goes back down. So that vertex is the highest point in my graph. So it's a maximum value. My AOS goes right through my vertex. So that's going to be x equals 0.5. Domain is still all real numbers. My range here does change because now all of my y values are going to be positive 4.5 or less because all those y values happen below my vertex now. So my range is just going to flip. So now my y values are less than or equal to 4.5 instead of greater than or equal to. So just be careful on that one. And now for my intervals of increasing and decreasing, the right side of my graph and my left side of my graph are just going to be flip-flop now. Because as you see, as you move from left to right on my graph, the left side increases until you hit the vertex, and then the right side decreases. So now my interval increasing is the left side, so everywhere where x is less than 0.5. And my interval of decreasing is the right side, which is everywhere x is greater than 0.5. All right, so the homework for tonight is a worksheet. I posted it on Google Classroom. It is, I think it's 8 problems, maybe it's 10, 9, somewhere around there. Problems very similar to this. I'm not as concerned with the intervals of increasing and decreasing because, again, that's something that's more so an upper level math characteristic. So on your homework that you're doing, all you have to do is identify the vertex, the AOS, the intercepts, and I think the max or the min. I don't even think I even bothered with domain and range for right now. But you'll see once you get to it, it's part of this process, not necessarily every single step of this process. As always, if you have questions, make sure you guys are reaching out and asking for help. If not, I will see you guys next time. Have a good one. Bye.